Okay, so the name of the game today, word problems with exponential functions, okay? So before we get too deep into the actual word problems here, I just want to refresh our memories a little bit, okay, about our exponential functions, right? An exponential function looks like this. Y equals a times b to the x. Okay, so that's what our goal is, to come up with a function that's in that format, a times b to the x. Okay? Sometimes, though, instead of an x, we could say it's sometimes going to be a t. Okay, so it could be x or t there, just as a heads up. Okay? Because, yes, x typically will represent time in these problems. Okay? It could be number of days, number of years, number of seconds. It really just depends. Okay? We can also use x's if that's what you prefer. Okay? Also, sometimes you'll see y equals p times b to the x, but again, it's the same idea as a. Okay, it's just like people using two different letters to mean the same thing. Okay, that number in front, that's like our initial or starting amount, or like our y-intercept, and that b, that's our growth factor or decay factor. Okay, the other thing I wanted to remember that b, okay, is equal to 1 plus r, or b is equal to 1 minus r, depending on whether we have a growth or a decay, right? So that's the other thing I want to remind us of there. It'll be on Google Classroom, yes, as long as the video doesn't fail on it. Okay? Okay? Growth or decay. We add r if we are growing. We subtract r if we're decaying. Jackson, those socks are pretty cool, man.
What socks?
They're Old Bay socks. Yeah. So, anywho. All right. Let's take a look at number 1. See what we think. All right. So number 1, we're going to find a bank account balance. Okay. And this is true, right? And this is like a simple way of calculating how interest works and stuff like that. But this is relatively true. So find a bank account balance if the account starts with $1,000, has an annual rate of 5%. Okay, it's interest rate, and the money stays in the account for 12 years. Okay, so that 5% annual rate, is that going to result in a growth of our money in the bank or the decay of the money in the bank? Growth, right? That's why you put money in the bank, right? As you hope it grows a little bit, okay, with the interest rates and stuff like that. Yeah, so we're expecting to have a growth here. Okay, we expect a growth. Okay. So we're going to come up with our equation here. All right. So let's again. I'm going to start kind of like writing some of the equation right here. So I'll do it right here. So f of x equals. Okay. What's our a here? What is our starting or initial amount? 1,000. Right here. There it is. Okay. Starts is the key word there. Starts with $1,000. So that's our a. Okay. So 1,000. Okay. Now our b. Remember, b, in this case, since it's a growth, b will be equal to 1 plus r. Okay. What is our r in this problem? What is our r? Okay, 5%. What is 5%, though, as a decimal? Anna? 0.05. You must be very careful with that because the temptation is for students to say, Mr. Whitmire, 5%, easy. It's 0.5. But 0.5 is not 5%. 0.5 is what percent? 50. So please be careful, okay? It's 1 plus 0.05 here, right? So b is 1 plus r, because again, we're growing, so we're adding our r. 1 plus 0.05, which is 1.05. So that's going to go there in parentheses, and then to the x. Okay, and what does x represent in this problem? X is the number of years, yes. Okay, so for our situation, we want to find how much money will be in the account after 12 years. So what should we do with that 12? Substitute it in for? It's a number of years, so it should go in for what? Yeah, so we'll say f of 12 equals 1,000 times 1.05 to the 12th. Okay, and we just type that into our calculators. So go ahead, type in your calculator, see what you get. Type that in your calculator, see what you get there. Someone got an answer for me? What we got? $1,795.86.
Okay,
yeah, so if you look here, right, there it is typed in, 1,000, parentheses, 1.05 to the 12th. You can see we get this long decimal here, but John rounded to 2 decimal places. And why does that make sense here? Because we're talking, what's the context, what's the meaning of this? It's money, right? And so we're talking about change, right? So we only want to go to the nearest hundred. Now, John rounded up, as he should have, right? Because you round up there to make it 6. Do you think banks in real life round? Nope. They just cut it off. So you don't get to keep that little fractions of cents there, okay? It's gone. It doesn't count, okay? They round down for you. Unless they're going to charge you a certain amount of money, and then they round up. So, but since this is money they're going to give to you, they will be rounding down, okay? So 1,795.86. We're going to follow correct rounding rules, but banks will not. Banks will not. They will take that money away from you, okay? That little fractions of a cent, which you're like, who cares? I get you, but I don't know. Some people care, right? Okay. Okay. It's like when you're at the gas station, right, and they give you 3 decimals after the dollar sign, right? If you ever go fill up for gas or whatever, the gas station always rounds up. So they'll always charge the next cent up for you. That's how they get a little more money. But there's our final answer. Okay, so after 12 years, if you put $1,000 into a bank account, 12 years later, you can expect to have $1,795.86. Okay? If you can find an account that will give you a 5% interest rate. But that's pretty high for a savings account or something like that. Okay? All right. Let's go number 2. In 1985, there were 270 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year after 1985. How many cell phone subscribers were in Centerville in 1995? Okay? So is this a growth or a decay here? Jackson, how do you know growth? What clued you in there?
Because it increased by 75%.
Increased by. So we got a growth. Exactly right. Okay. Very good. All right. So let's go then to write our function here. What's our initial or starting amount here? Yeah, Olivia, go ahead. Very good. Yeah, 270 is where we're starting. Okay. That's our starting amount. Okay, we're kind of counting from 1985, right? We're growing from 1985. We're counting from 1985 there. So, yeah, 270. And then in parentheses, our B. Okay, now we've got to figure out our B. B is 1 plus R. Again, we're growing here, so we're going to add our R here. What is R in this particular problem? What is R? 0.75. Olivia, is that what you're going to say, 0.75?
I was going to say
75%, which is the same thing as the decimal. Yeah, question? You good, Anna? Okay. So, yeah, we're going to use 0.75. So 1 plus 0.75 equals 1.75. Okay, so 1.75 goes in for our B. And again, to the X. And what does X represent here? Number of what? X represents the number of cell phone subscribers? Well, so, yeah, that's a good question here. We have 2 unknowns, right? We have a number of cell phone subscribers. We also have a certain number of years that have passed, too, right? So in this case, X is going to be the number of years. And then our answer that we get there, Cameron, at the end, that'll be a number of cell phone subscribers. So, yeah, number of years. Okay? Now, it's more than just number of years, though. It's number of years since what? Since 1985, yes. This one's a little bit different because we're given the year it starts, okay? And the first one, we were just saying, hey, 12 years later. This one's saying in 1985, you have this much. So we have to say since 1985 there, okay? We want to figure out how many cell phone subscribers were in Centerville in 1995. Should I put 1995 in for my X? But 1995 is a number of years. Yeah, okay, folks, we started in 1985, and then we go to 1995. That is a time of 10 years later. So it's 10 that goes in for x here. If you put 1995 in for x, you're going to have a number so big your calculator is going to say overflow. It's not going to work.
Or error.
Yeah, it'll say error overflow. I'm pretty sure. Let me try to type it in and make sure. Yeah, see? If you type in 270 times 1.75 to the 1995, you're going to get overflow. That's how you know you did something wrong, okay? Overflow. That number's so big the calculator can't even handle it. Okay? So you have to find how much time has elapsed. Okay, 10 years. And so that's what you're going to type in. Okay, and we get 72,735 point. Now here's the question, right? Should we round to a decimal point here? Yeah, I mean, people really aren't, you can't really have fraction of people, right? Even if you're missing a limb or something like that, you're still a whole person, right? So 72,735 is going to be our answer, people. Okay. Error? 1.75, yes. Yes, Hannah will always be taking that percent, and will either be adding the percent to 1 or subtracting the percent from one hand, depending on whether they're doing a growth or decay. Okay? Okay. This next one, let's try this next one here. Okay, bacteria can multiply at an alarming rate when each bacteria splits into 2 new cells, thus doubling. If we start with only one bacteria, which can double every hour, how many bacteria will we have by the end of the day by the end of one day? Okay? So is this a growth or a decay here? Growth, right? We're growing bacteria. Okay. What's our starting or initial amount of bacteria here? 1. Yeah, we're starting with only 1 bacteria. So 1 times, and now I got to figure out our growth rate here. Okay? So some of you might be able to figure out. So this gets a little tricky. Okay, Sky, what do you say? So 2 is what would go in parentheses here, yes. 2 is what goes in parentheses. So I'll go ahead and put that in here. Okay? 2 is what goes in parentheses. But we skipped a step. Normally when we do this, right, we think to ourselves, okay, B is going to be 1 plus R, because again, it's a growth, so 1 plus R. And normally we're given like a percent change here. But do you see any percents given to us in this problem? No. That's right. But yeah, the percent here, because we start with 1 bacteria and then it will split into 2, that means we're adding 100% more to the thing here. So our R is a 1 here. Okay, we're adding 100%. Okay, but Sky, correctly, you can just bypass that here. If you're doubling, then you're just going to put a 2 in there to the X. Okay, what does X represent here? A number of what? Yeah, not number of years, number of hours. Okay, number of hours. Okay. Bacteria does not need years to grow, right? Bacteria grows rapidly. That's why we have problems with getting sick and things, right? So, all right, let's set it up here then. F of x equals 1 times 2 to the, oops, I don't want to put f of x, sorry, my bad. What's going to be our time here? How much time are we going to talk about? 1 day is 24 hours. So we're going to do f of 24. Sorry, I meant to put a 24 in for the x there. Times 2 to the 24th. Okay. How many bacteria is that? That's a lot of bacteria. And that's not rounded, that's precise, right? 16,777,216 bacteria. That's a lot of bacteria. That's why you got to wash your hands. Okay? Yeah. Okay. Questions on any of that? All right, let's go on to number 4 because we haven't seen any decay questions yet. Hopefully we'll see a decay question here. All right. So number 4. Each year, the local country club sponsors a tennis tournament. Play starts with 128 participants. During each round, half of the players are eliminated. How many players remain after 4 rounds? So is this a growth or decay? Decay. Why?
Because it's going down.
What? Yeah, we're losing participants, right? So it decay. Okay. What's our starting or initial amount here? 128. Okay, so 128 times, and then our B value here. What's our B value going to be?
4.
B is 4? Not 4. Yeah, it's going to be 1/2. So if you think about it here, again, in this case, since it's a decay, it'll be B equals 1 minus R. Our decay rate, well, we lose 50%. We lose half each time, so that's 50%. So we're going to subtract 1 minus 0.5, which, well, it's also 0.5, right? So we'll just do 0.5 there to the x, right? In this case, x represents the number of years, hours. What does x represent here? Rounds, number of rounds. Okay, number of rounds. Okay. And in our particular case, how many rounds are we interested in? 4. So we'll do f of 4 equals 128 times 0.5 to the 4th. Okay. So after 4 rounds and eliminating half of the players per round, how many players are going to be left? 8. Wow, 8 players. 8 players. All right, so questions on any of that? All right, if not, then I want you guys to go ahead and try 5 and 6. Okay, 5 and 6. Try those 2. Okay. There is going to be a quick check tomorrow on questions like these. Okay, so we want to make sure we're getting this stuff down. Okay, I can tell by the inflection in your voice.
Can I use the restroom before we start?
Yeah.
Are we doing another sheet after this?
Yes, there'll be another paper after this. Yes. I know. More. Okay. So 5 and 6, please. Give them a try. I'll come around and help here. Summer dew. Spring dew. Now the last 3, John, are a little bit funky, but you want the next one too? I see it. You have to. Just get to it.
All before you start.
Okay. All right, see how we're doing here, folks. So again, identify, is it a growth or decay? Yes. Looks good, yeah. Yeah. Really? Oh, you put a comma. They don't like commas in there for whatever reason. You don't need them. Well, but I mean, you know, she's doing it right though. I mean, that's cool. Yeah. Don't forget the x. And remember, it's being 1.07 to the x. Yes. Because you take this and you add it to 1. You add it to 1 plus 2. Yeah, that looks good. Yes. Yes, please. Yes, 5 and 6. Okay. Close. 7% is not point. It's going to be 0.07, not 0.7.
Oh my god, these age units would take that.
Put the x for this one, and then you show this one down here, and then this one the x. Same thing here. You put this one down here, and you put x there. But that's okay for now. Just to make sure you put everything in the right spot. That's all. I kind of hope we're good so far.
But it's fine because I'm
Sounds good. Yeah. What is 1 minus Q.
R is what?
So it's like 0.7%.
It's happening around 7%.
That's what your decay.
0.07, right? 0.07.
Yeah, that's good. Make sure you put an X for the exponent. Okay. And then answer the question. Okay. You're going to tell how many years passed. So you got to put a number of years in for X. You don't want to put in 2011. That's another year. But how many years since it started? It started in 1960. How many years I did that? Okay. Yes. Correct. Right. And the idea is try this one too. So I can see it happen. This morning it was, yeah. So you're close.
I feel like charging like every hour.
The B value is 1 plus R. This, so answer your question real quick. So start at this 7%, that is R. Okay? Go of course, we write that as a decimal, so it's 0.07. Right? Okay. And then B, because it's growing plus R, plus percent. We write it as 7%. This. Okay. Equals 1 plus. And so the decay is subtract your R. Okay. 0.29. So be careful, that's your R. You do 1 minus R to get your B value here. Okay? This is your decay rate.
They're almost the same. They're fun.
So since you're decaying, B is 1 minus R. So it's 1 minus 2. That's your B value. Okay? Just like you took your sunrise X there, so here you just add 1 because X represented what?
It's the same exact thing.
I know. And then number 4.
It's okay.
See?
Yeah, no, it's too tough. So far.
Good die. It's more.
Yeah.
Stuck? Frustrated? Bored? Sad? Hungry? What's that? Why don't you get this on? Give up? So you want your parent? Play the question.
What should I call this one?
What do you think it is? So, anytime you want to write a percentage of decimal, take a percent, 29. Divide it by 100.
See that in your equation? So you're going to plug in
Oh, John.
frets. It's having round
29. Right?
It died.
Any percent you can do that. Okay? But then you're not. That's not your B though. 0.29 is not your B.
I'm not gonna give up.
R is 0.29. So you're gonna do 1 minus 0.29. That's your B.
No, I'm not getting up.
It's actually pretty easy.
Yeah.
I need a new calculator.
Shall I go? Throw away for you?
Yeah, this is like kind of
Yeah, I'll put it in the charger. I don't have a spare calculator. I can. I'll be right there. 1 sec.
No.
You're bad at the game. So close.
Excuse me. All right, like 30 more seconds here, folks. We're going to go over this.
That was only one time.
I'm coming.
You're not good anymore.
Very good idea. Decrease with subtract. Depends which quiz out.
I do this for
Check the quiz out. Yep, quiz. Quiz average.
You didn't start yet. You know what?
folks, let's go over this here. So, eyes up front, back to our seats, please. All right, we'll go over this number 5. Okay, number 5. Is it growth or decay? Growth. Yes. Okay, how do we know? Land increased. The value of the land increased by approximately 7% year to year. Okay, what is our starting or initial amount? 30,000. Wowie. Wow, wow. Okay, our B value, B is equal to 1 plus R. We are adding our growth rate there. Okay, Erica, what is our growth rate here? We are growing at what percent here? Number 5. Okay, 0.07. Be careful with that. Yeah, because 0.7 is 70%. That'd be a crazy growth rate, right? 0.07, maybe more realistic. So we get 1.07 there to the X. Okay, what does X represent in this problem? Number of years since 1960. Okay. Okay. How many years passed from 1960 to 2011, right? So that's our hint here. Okay, 51. Yeah, we got to put 51 in. Thank you, Olivia, for volunteering too. Okay. 51 goes in for X. We put 51 in for X because we're not going to plug in 2011. We started in 1960, so we're not going 2011 years out, right? We're going from 1960 to 2011. That's 51 years of time, okay? So that's why we only go 51 there. To the 51. Okay, so I get about 945,570.50, we'll say.
Or 5.
Okay. Or 5, that's fine, yeah. And this is in dollars.
Or that is just so much money.
It is. It is. Okay. But you also have to think, too, back in 1960s, right, when they first bought this for $30,000, a dollar was worth more then, too. You know what I'm saying? Like today, like back then, maybe you could buy a loaf of bread for 50 cents, whereas today it might be like $3 for a loaf of bread.
That's pretty nice.
So the idea is, right, so the dollar was worth more back then, too. So it's still probably a good growth, but there is such a thing as inflation. All right. All right. Number 6, an adult takes 400 milligrams of ibuprofen. Each hour, the amount of ibuprofen in the person's system decreases by about 29%. Folks, this is your body doing what it's supposed to do, right? When you take medicine, right, your body metabolizes medicine. Even though medicine is supposed to be there to help you, right, your body metabolizes the medicine out of your system, okay? Because you don't want to keep it in there forever, right? And so your body kind of takes care of it, okay? Cleans it out, like your liver and stuff like that, okay? That's why you have to take it every so often, because your body, diminishes how much is inside of you, okay? So, in this case, right, we're saying each hour the amount of ibuprofen, and I know that's like that is how you pronounce that word. It looks like ibuprofen, but it's ibuprofen. I don't know why they spell it that way, but anyway. And the person's system decreases by about 29%. Okay, about how much ibuprofen is left after 6 hours. Is this a growth or a decay? Decay, right? We don't want our body producing more ibuprofen. Make us very sick if that happened. Okay. So, it's decay. What's our starting or initial amount? 400 mgs, milligrams, right? That's like a tablet or two, All right, our B value here. Is B going to be 1 plus R or 1 minus R? 1 minus R. We are decreasing every time, right? 1 minus R. Very good. Okay. What is R in this case? What is R? What's our rate? What's our percent change here? 29%. Okay, so it's 1 minus, as a decimal though, 0.29, and so we get 0.71. Okay.
And that's for
per every, so our X there, and what does X represent? X is the number of hours. Okay, so after 6 hours, Okay, well, let's see what happens here. So we'll do f of 6, 400 times 0.71 to the 6th. Okay, we get 51.24 milligrams. Okay, just like that. And of course, different people's bodies metabolize things at different speeds and stuff like that. But this is definitely something that, you know, happens. This is how it works. Okay. Okay. 51.24 mgs. Alrighty. Questions on any of this? All right, we're gonna have one more paper here then. Do a little more. Put it back? Yes. Oh, I already got one. Thank you. Yes, there you go. Sorry, Erica. There you go. Sorry? Yeah. Okay. This idea, by the way, folks, where we take 1 minus r or 1 plus r, you can use this in a lot of different situations. For example, if you want to calculate tax, right? So like, you know, when you go to a store and you want to buy something, right, the price on the sticker, right, is not what you end up paying. You end up paying 6% more than that, right? It's a 6% increase. So what do? You can take your price and multiply by 1.06, right? 1 plus that 0.06 rate of change, right? Okay. You can also use this when you go to the store and you want to, like, you know, buy something that's on sale. Okay, 20% off, right? 20% off. That means you would take the b of 1 and you'd subtract 0.2. So it's 0.8 then, right? 1 minus 0.2 is 0.8. So when you buy something for 20% off, that means you're buying it for 80% of its price, right? So 0.8. So you can use these like things in your like everyday life. This is something where, you know, you're going to see that show up, you know, in real life. You can predict. And then if you want to get even crazier, you can then multiply that answer by 1.06 to see how much tax you're going to pay on top of the price too. So anyway, those are helpful. Okay, so let's take a look here. We'll do a few more of these. All right. Let me think here. One thing I want to point out here, 8, 9, and 10, we're going to talk about some of these tomorrow. Okay, 8, 9, and 10 are a little bit funky here. So you can like, you know, I don't know what I want to do here, but just, you don't have to worry about 8, 9, or 10 here. Okay, what I would like to leave for you guys to do, well, let me see here. How do I want to do this? I feel like I zipped through things a little bit here.
I have a question.
Yeah.
Where's number 7?
Number 7. Gone. It's gone. So we're going to hold off on 8, 9, and 10 for right now. Don't worry about those. All right. Let's flip over here. We'll pick 2. All right. So you guys pick one for me. 1 through 6. Which one do you want to work on? 2. I heard 2 first. All right. 2. Hey, wait a minute. Centerville, 1985. This isn't the same exact problem, is it? Nope, there's a little bit difference. This one starts at 270, not 280, so that's okay. Whew. Okay, we're back in Centerville talking about their cell phone subscribers, but it's a different Centerville because there's 285 this time. Okay? Now, okay, in 1985, there were 285 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year after 1985. Write the growth model and calculate how many cell phone subscribers were in Centerville in 1994. So this is growth, right? So we're going to have y equals a times b to the x. Okay? So what is a in this problem? What's our starting amount? 285. Very good. Okay, right there. There's our a. 285. Okay. What about our B? Well, B is going to be 1 plus R here. Okay. What's our growth rate here? What's R? What's our percent growth here? What's our percent growth here, folks? Number 2. Okay, so 0.75 for the rate, and then yeah, we're going to add that to 1 to make 1.75. So we'll put that in for the B. Okay, 1.75 to the X. Yeah, what does X represent in this case, guys? The number of years? Just that? Yeah, X is number of years since 1985. 1985, man, that's a pretty good year.
One good year.
All right, year since 1985. So then what will go into X here? Do I put 1994 in for X?
No.
Because I want to find the subscribers in 94?
That will be an overflow.
It would be an overflow. How many years since 1985 is the year 1994?
9.
9 years. So we're going to say 285 times 1.75 to the 9th. Okay, Lauren, go for it. 871 cell phone subscribers. You round up to 2. Yeah, and so that's where it's going to get tricky, right? It's like, well, should we round up to 2? Should we not round up to 2? I think you can make arguments either way. On the one hand, Lauren might say, well, you didn't quite make it up to that other person, and since we don't really count fractions of people, we should probably round down. But Frank might say, yeah, but traditional rounding rules say we should round up, so we'll round up to 2. Either one I can see the argument for, so you're really okay with either one, okay? There'll be a little bit of give or take there, okay? The directions may specify how to round, though. Please do follow those. All right, we got number 2 done. Give me another one. Between 1 and 6, not 2. Oh, I heard 4. Number 4. Okay. Hey, look. Each year, local country club sponsors tennis tournament. They start with 128. Yeah, it's after 5 rounds this time. Okay. So y equals a times b to the x. What are we starting with here? What's our a? 128. Is this going to be a growth or a decay in this situation? Decay, right? We're losing players. We're eliminating them. So our b value is going to be 1 minus r. What is our percent here? We're not told percent. There's no percentage listed up here, but we have to kind of interpret it. What is the percent here? Half. So half is what percent? 50. So we'll do 1 minus 0.5, which is 0.5. Okay. To the x. X in this case, x is a number of what? Rounds, yes. Number of rounds. Crazy Reagan. There she goes again. Crazy kid. All right, number of rounds, number of rounds. So in this case, x is going to be what? 5. Okay. So we get 4 players. Okay. It's kind of like the NCAA tournament, right? You start with 64 teams. Then you go down to 32, half, right? And you have again Sweet 16, Elite 8, Final 4.
And national championship.
And the championship, right? And there's 2 there, right? Yeah. And then half again, the champion. 1, right?
And then
1 team still remaining.
And it ends there.
And then you have half a team, right? And then you have cut that team in half and half.
Well, you can't really do that.
No, you can't do that, yeah. Okay. Yeah, you go down to 1 team and then you stop, right? You don't start cutting players in half. All right? That's just too dark.
That's just players playing against each other.
That's right. All right, folks. So, with remaining time in class, I would like you to finish 1, 3, 5, and 6. Okay. So remaining time in class: 1, 3, 5, 6.
1, 3, 5,
1, 3, 5, 6. It's 4 problems. Oh, right, and 7.
Why does it say, why did you skip 6?
Sierra said we don't need 7. All right, Sierra, since you said no 7, we won't do number 7.
I think you should take 7 and not do 6.
I know, it's no
Well,
7.
that's the real 6. So this is
April
supposed to be 7,
Fools.
this is supposed to be 8, and there's no 10s.
Okay, so 1, 3, 5, and 6. And you know what? 1, 3, 5, 6, just pick 2. Pick 2. I need 2.
You put 7 up there too.
Sorry,
So I can pick that one.
Yes.
Yeah.
Yes. But please do work on them, okay? Yes. Yes, if you don't finish in class.
Mr. Wood, did you want the sheet that I got?
I'll check tomorrow.
Me too.
Extra.
I don't like the if you don't get it exactly 600, you have to like say like 2.5. Is that what you got?
I got like
They said after how many years, so I had to put 2 or 3.
Cameron, Alex, gentlemen, back to your seats. This is not time to go and socialize. When you go back to your seat and get to work on the problems that I assigned. If you're done, you just stay there, okay? This is not time to go and socialize, all right? Remember also, folks, we are not lining up. You're staying at your seats until the bell rings, okay? I'm tired of having to go out and walk like that. Right? So you're staying at your seats.
So there was no like specific answer. Because all of them wouldn't
All right.
give
Well, I mean, I want you to you can work on it right now.
you
Well,
wouldn't get 600.
we can do the extra problems then tonight.
You get more than 600 or less than 600?
What's that?
Yeah.
Have a Band-Aid? I do. Let me see here. Actually, I might be running low, but let me see.
There's like